Hello, everybody. Welcome to what is now our 16th webinar on all things that support building electrification. My name is Steve Miller. I'm your host tonight. Tonight's show is quite popular. We have over 100 people who are registered. We're going to give you ample time to ask questions so that you will learn how to halt your own greenhouse gas emissions. My wife, Pat Miller, will handle tonight's Q&A. Pat, tell them how it's going to work.
Yeah, we're going to hold the questions until the presenters have finished their presentation. But if you think of questions before then, you can put them in the chat, and then I'll ask the questions at the end after they finish speaking.
Very good. So tonight I am pleased.
Oh, and everybody mute yourselves.
Yes,
Forgot
thank you.
that.
So I'm pleased tonight to bring back John and Diane. This is actually for the third time. The first two were in 2021, and it was about them talking about their future passive dream house. And tonight they are living in that dream house, and they're going to take us through the design and construction of their new highly efficient house. This is the culmination of their 10-year dream to build a passive house in order to do their part to stop polluting the earth and to halt global heating and climate change. John is a professor of economics and finance at Monmouth University. John's profession allowed him to understand the money-saving opportunity to build a passive house and do his part to sustain the environment for humanity's future. Diane is an evangelist for the earth and for halting climate change, and she is putting her efforts into her new house, which leaves very little carbon footprint. And she will talk with pride about her organic farm. And that's your introduction, John and Diane. The floor is now yours.
Great.
Thank you.
Thanks, everybody, and welcome. You want me to go or you go?
You go.
All right, I'll go. Well, yeah, as Steve said, it's been a long dream of ours to build a passive house. And well, I should caution you, we did not get this house certified as passive. But we built it to what we believe to be passive standards. So high performance, zero energy, those all work, but we shouldn't really be calling it a passive house, I guess, because we didn't get it certified. Anyways, we're very happy to be living in it now. And so far it's been fantastic. So we'll walk you through it. Here's what we're going to cover. Steve asked us to cover the 5 principles of passive house, so we'll do that. We'll talk about how is it working so far. We've really been in here about 2 months, and so we can talk a little bit about that. Problems and obstacles we encountered and had to overcome to get it done. What's it like to live in, which will give you a little preview. It's really good. And the organic garden, native plants, Diane's passion. And then we'll have Q&A. So yeah, as Pat mentioned, please, hold the questions to the end, and then you can put them in the chat and we'll try to cover everything. So the 5 principles of passive house, here they are. No thermal bridging. So the walls, floors, and roof are extremely well insulated, and trying to minimize or eliminate thermal bridging, which is how heat transfers, pretty much going from hot to cold. Hot's going to always find a way to go to the cold, and you don't want that happening in your house either direction. Superior windows are really important, and we've done that. We'll cover those. We'll cover each of these areas specifically. Energy ventilation, which is one of the really cool things about these houses. When we first started, I didn't know about this, and when I found out about it, I thought it was really interesting. And now seeing it really work in life, in real life, it's fascinating. It really works well. Quality of construction is very important. You don't want any leaks. Everything's got to fit together properly and be well made. And leads to the last thing, airtight construction. We don't want any air getting into or out of the house other than what we want to do in a controlled fashion. So the no thermal bridging. So here's a picture of our house being built, and we'll go through how it was built in a second. But you can see these panels. There's a crane putting the panels down on our foundation. Those are 18 inches thick as opposed to a regular 2x4 construction house. And they're packed with dense cellulose built inside a factory. So it's very energy efficient. It's very difficult for heat to transfer across there. Everything is built to perfect tolerances. So everything fits together and they bolted them together. So there's no air gaps. There's our foundation. And we've actually built a slab, which we'll talk about. But you can see it doesn't look like a slab there. It's starting to look like a basement. And so the thing is not just a slab on the surface, but the footings are down 5 feet. So any cold that wants to enter the house is going to have to go down 5 feet and then back up. And if you go down 5 feet, it's 55 degrees all the time in the winter, in the summer. So that's a way they control the heat with a slab. There's insulation on the outside of the foundation. And there's the finished slab before the panels came. There's the panels actually arriving. We had 7 semi-tractor trailers of the panels arrive, and a big crane that kind of assembled them sort of like Lego, and it went pretty quickly. So the second thing was windows. So the windows we have are triple pane windows, which I'd never seen before, versus double pane. And here I put the R values. You can see triple pane are more than twice as efficient as double pane. And windows are really the biggest source of heat transfer from a house. So it's pretty important. We like windows and we wanted big ones. And so it's even important for us to, more important to have good ones, right? So they're really cool. They're European, and you can see it's closed. You can open them that way, like a door, like the middle picture, or you can also move the handle all the way up and they pop out. So, the wind won't blow it open and close, or if it's raining out, you can still have it open there and rain's not going to come in. So they're really pretty cool windows. We like them a lot. And there's screens that fit right on the outside. So of course, on a nice day, we'll have the windows open and enjoy, the nice atmosphere outside. Here's the energy recovery ventilation, which is critical to passive house. And this is one of the really interesting things that I did not know about before we started this. And when I found out about it, I was kind of fascinated by it. And now to see it work in real life, I mean, at first I was, I guess, skeptically optimistic. And now that I see it working, I'm just amazed. But so the concept is, it's a heat exchanger. So this image on the left, so you take air from the outside. So this would be in the summer. So the air is warm and moist. So you take that air in, pass it through this heat exchanger in the middle, where then the stale air from the house is coming in on top here, also going through there. And the idea is then we want to preserve the cool inside the house in the summer. And so it's going to transfer the cool back into the incoming fresh air. And then the exhaust air goes out warmer. So the moisture is controlled and the heat is controlled. So that's the concept. This is the unit we actually got. It's a Zehnder. I think it's Swiss. It's one of the higher end units, and we wanted to get that one. And you can see the 4 ducts for the 4 purposes. From the house coming in, intake from the house, going back into the house. And then fresh air coming in air coming in the outside, and the exhaust going back out the outside. So there's the 4 things. Here is, the thing came with an app, so we can see what it's doing real time. And so the first time I did this, I was really kind of blown away. So you can see this was a day when it was 9 degrees Fahrenheit outside. It was cold, very cold. And you can see that's our outside temperature. And if we look at the extract air, that's the air that it's taking out of our room. So the rooms in the house were 68 degrees, and it was 9 degrees outside. So we're taking that extract air and putting it through the heat exchanger, taking in the fresh air. And then the supply air, the air that's coming back in the house, is 62 degrees. So I took the ratio of the supply air coming into the house minus the outdoor temperature, 9, divided by the extract minus the outdoor, which is so the smaller ratio divided by the bigger one. And basically we get about almost 90% efficiency. That it's recapturing about 90% of the heat, which, when I saw that in real life, I was amazed. That's really cool. A regular house, you're going to take in that 9-degree air and it's fresh, but now you're going to have to heat your house up a lot more. So this thing is critical to making the whole house function properly. The other thing we have, if I went back there, we'd see that we're always losing a little bit of temperature over time. So we're going to want to either get the temperature back up in the winter or back down in the summer. And instead of using, natural gas for heat in the winter and burning fossil fuels, we're using a thing called a heat pump. So that's an electromechanical device. It's not electric heat like baseboard heat, like you might be familiar with, which is resistance heat, but these are actually pumps. So they've got refrigerant or coolant, and it basically runs the coolant into a compressor. And as you compress things, that creates condensation. And if you remember from your physics or science classes, there's latent heat of condensation and latent heat of evaporation. So when you compress things, you're going to generate heat. And then when things expand, when they evaporate, you're going to create cool. So if you ever walk by like a fountain or anything outside on a hot summer day, you'll feel how it's cooler all around there. That's from the latent heat of evaporation. So basically this system is a closed loop system, and it's using a compressor to compress, and it goes one way in the winter and it goes the other way in the summer. Another way to understand it is think of your refrigerator. You open your refrigerator, it's cold inside, but the back of it, where all the coils are, is hot. And so in the winter, the back hot side would be facing your house and the cold side would be outside. And in the summer, you'd basically reverse the process, and you're going to have the cold inside and the hot outside. So you could think of it that way. So between the ERV and the heat pumps, you get a really efficient thing. The last piece of the puzzle you need is you don't want any other air leakage. So you want the house to be really airtight, and everything goes through the ERV. And then the heat pump does the rest of the work. One of the other principles was quality construction. So this is an image. We used a company called Unity Homes. And whenever they build a home like ours or any other one, you go through a series of iterations with them. What do you want your house to look like? You can start with one of their models. You can start with a complete new design of your own. And then you can change things around. We want this room bigger. We want to mirror image that, etc. You finally settle on what you want. They do it all in computer-aided design. So they build the whole model on a computer, which consists of every single component. And then they make those components indoors in a factory, right? So all the little pieces go together. And there you can see they're making the panels. So they're putting the panels together, and they put the windows in the panels in the factory, and then the whole thing arrives. So there's some of the panels standing up. And here is probably 1 or 2 panels just sitting there. And you can see this is the assembly of our house. So you can see that the panels they've put up, and they're putting the floors on at this point. So they put together the pieces. They all fit extremely precisely because they were designed perfectly, and they're built to exact tolerances, and everything fits. And it did. This crew came and they had our house up in 2 weeks from a foundation to a full standing house in 2 weeks. We then had to finish the exterior and the interior, which we hired a local GC to do. Airtight construction is another one of the principles, and another one of the important ones that goes hand in hand with the ERV. So you don't want any air going in and out of your house other than goes through the ERV. So they have a way to test that. They call it the blower door test. And there's a thing of what it looks like. You get a thing that cover up your front door. There's a fan and a pressure sensor, and they're going to create a vacuum in your house and see how long it takes for the vacuum to go away. And what they do is they measure it in ACH. So that means air changes per hour. And ACH 50 means air changes per hour at 50 pascals, which is a measure of pressure, which isn't very much pressure. So here is our house after they put it all together. Then they did the blower door test and tested. And so we had 0.227 air changes per hour. So that's, about how much air could go in and out of our house on its own with the vacuum, which is well below the passive standard is what we'll see coming up. So these are, how's it working so far? So I was on the air change per hour. The passive standard is the middle one. 0.6 is what they want to see for the passive house standard. And we achieved 0.2. Less is better in this case. So we're quite a bit better. Frankly, Unity said this is the best result they've seen so far. So I guess they're getting better as they go. One of the other passive house standards is total energy usage. So it's European, so they want 60 kilowatt hours per square meter of your house, not square feet, but square meter per year. So I did an estimate for our house so far, and I'll touch on that next. But I think we're coming out below that, which is good. So we'll give us a check here too. And I'm impressed that in the winter we're coming out below. I think in the spring and the fall will be our easier months, and the winter and summer will probably be our higher energy use months. So far, so good. So far, I think we're looking really good on the things we can measure. The third standard they have is thermal comfort. So they want less than 10% of the days to be greater than 25 degrees centigrade, which is about 77 degrees Fahrenheit in the house. So I think we'll be way ahead of that too. But so far, we don't have a whole year to compare. So this is how I estimated our energy use. As I mentioned, we got our first utility bill and it was estimated. So they didn't do the actual meter readings. So I've been going out and looking at our meter myself. So I did my own meter readings just to see how we're doing. So you can see the actual meter readings on the dates here below in the gray. And I can figure out then what's our daily kilowatt hour usage. So we're averaging about 80 kilowatts per day, which would be about 2,400 a month. JCP&L is charging us about 9 cents a kilowatt hour. So our total utility bill is going to be about $225 a month. We have 2 electric vehicles. We have a Tesla and a Rivian truck. And we drive them both a lot, or, they're our primary vehicles. So I think we use them about 40 miles a day. And this is how many miles per kilowatt hour they get. And so here's my estimate for how many kilowatt hours we're using for those. So in other words, we're not buying gasoline. We're running those also from the power of our house. So there's our usage there. And we ended up, oh yeah, and there's a third one. Okay, because we want to get solar, right, to fill in our actual electricity usage. And they're going to want to see our real utility bills before they tell us how much solar we can have. So we're trying to run up our electric usage a lot. So we asked a friend of ours to come over and charge his Tesla here as often as he can. So he comes over maybe once a week and charges his car up too. So we put him down for 200 kilowatts a month here. So I think our estimated usage of our vehicles, our 2 and our friends, is about 1,100 of the 2,400 kilowatts. It's 47%. So I was kind of surprised that it's that much going to vehicles, but other people told me, they're seeing the same thing. So this is where we came out, hey, that number should be less than the 60. So we take, our total usage less the usage of our electric vehicles. The remainder then is what is the house using. So that house number times 12, and then divided by square meters per year, we get 56, which is below their standard of 60. So that's our best guess right now. I think it's that. I'm happy that it, looks good. Steve asked us to touch on problems and obstacles. So here's a little slide on that. The first one was inflation. And I mentioned, so we had Unity do the panelized thing, and that was nice because we locked in a deal with them. We agreed to buy that for X amount of money. They held their side of the deal, and we purchased the panels and they installed them for the price we negotiated. Then we got our general contractor in there to finish the exterior and interior, which included electricity and plumbing. And we just constantly heard, you won't believe I used to pay 20 bucks for a box of nails, now they're 80. You won't believe plywood used to be 15 bucks, now it's 80, you know. And so I actually looked some of these things up, and you know, what GC was saying is things have doubled, tripled, quadrupled. And yeah, you see them here. This is the price of plywood. You know, it went from, you know, just before COVID, around when we started, to, you know, a peak of 250% increase. So it gets right around where we were buying it, right there. Electric wire, same thing. You know, it's up 360%. PVC, all the pipes for the plumbing and conduit, 280. So those percent increases are much bigger than, you know, what we're hearing on personal consumption expenditures or CPI inflation numbers, which are on the order of 6-7%. So yeah, construction materials really went up a lot, and we felt that, and we spent a lot more to do the completion of our house than we initially estimated. Variances and permits. So yeah, you know, in our town, I guess that's always an obstacle. It has nothing to do with our house or the fact that it, you know, it's passive standards. It's just normal stuff that we had to go through, and it took a long time, but we got it done. Here's a key thing, and for us, it wasn't a problem or an obstacle. We got lucky. We got a really good general contractor. This is his first passive house that he's done. But he was very open-minded. He wasn't the kind of guy that said, hey, I've been building houses for 40 years. I know what I'm doing. Leave me alone. He was eager to learn. He was in constant contact with Unity about how to do things and what not to do. So he was fantastic on that. And I think that's really important. You know, the best would be to get someone who's already built one of these, or, you know, finished one of these. But at least someone who's open-minded and eager to learn new stuff, because there's a lot of new stuff. The thermal barrier, like, you cannot just go drilling holes through the exterior walls, because that's the thermal barrier. You know, so if you want a new water outlet or a new outlet outside, you can't just drill a hole through there. It's very, you know, it's 18 inches thick, and you got to make sure everything is done right. And actually everything was designed in the first place. So I'm happy to report we didn't drill any additional new holes. It's just, everything was as planned. So you can't permeate the thermal barrier, the outside barrier of the house. Here's a problem. As I mentioned, we don't have a basement. And when we were first working with Unity, the people who supplied the house, they're like, you guys want a basement? And we're like, yeah, we want a basement. Like, okay, well, that's going to be 110,000 more. And we're like, yeah, maybe we don't need a basement. So we said, let's skip that, because it's just two of us and we don't need as much space. And then you could see when we built the house, they put the foundation, the walls down 5 feet. When our mason saw that, and here's the plan. So they gave them a very specific plan. You know, you don't just go build a slab, you got to build it exactly like Unity says. And he saw that and he's like, hey, I you know, for like 20,000 more, you could have had a basement. So we went back to Unity and said, hey, we want the basement now. And they basically said, it's too late. Your stuff's already built. It's built to be on a slab. You'd need a separate floor system. We'd have to redo everything, start over. So we proceeded ahead without a basement. So in hindsight, yeah, I think we were a little naive or misled that, you know, wouldn't have really cost a marginal 110. That foundation pretty much costs like 80 or 90,000 to do that, not 30, you know, or 20 or whatever. So on the margin, it would not have been that much more to actually give us a basement. So in hindsight, I wish we did that. Other things we screwed up. I didn't factor in getting the power to the house. We're in a place with a lot of property here, and it's 300 feet from the house to where we would put the new power. I'm like, yeah, okay, let's put the power in. So they got to dig a 300-foot trench, put 300 feet of thick copper wire, because we have 400 amp service. And we had to pay for a telephone pole and a transformer on that. So all that was about $65,000. So I was like, oh, okay, we didn't have that figured in at all. So that's another thing we kind of screwed up a little bit. So living in it, I think maybe I'll turn it over to Diane and let her take over from here. You want to do the living in it?
Okay, sure. I'm going to be doing the garden and that stuff, but this is so this is our house. You can see it's basically one big living space. So that's our living room, dining room, and kitchen, and we love it. It's just perfect for us. We have a master bedroom downstairs for our forever house, so we don't have to worry about going upstairs, although we're upstairs right now. And laundry room is downstairs, and 2-car garage, and it's just really comfortable for us. And I have to say, with the ERV, the HVAC system, the house is the warmest it's ever been. Because for me, I never was comfortable with forced hot air. It just dried me up. It just felt so uncomfortable. So John and I would fight over the thermostat.
Yeah,
and
constantly.
he's always warm now. He's not with a coat on and mittens and watching TV. And I think the air, if you come here and you feel the atmosphere of the house, it's very clean. It's really quiet. And it's really comfortable, almost like the 68 degrees is more like a 68-degree outside rather than inside. And then just before we get started with the garden, as you can see, the foundation of the house here and in other pictures, we have no landscaping around the house at all. So we basically have a blank slate for landscaping. And so that's why I'll talk about that. I just wanted you to see that there's no foundation planting or anything. It's a blank slate.
And you know what else? I mean, one other thing, living in it, it's very solid. Like if you bang on a wall, it's a thick, solid wall. It doesn't feel like a regular house's wall. It feels more like a commercial building or something. It just doesn't move or vibrate. It's just thump solid. So everything feels high quality. So we're very happy with it.
How do you do that?
Oh, you just left click.
Okay, so during COVID, well, when we acquired this house, we bought this house right when COVID started, and it came with this big tennis court, dilapidated tennis court. So you can kind of see this aerial view. We took the asphalt out, and we were John and I built all these boxes. So they're raised beds, and I don't know, 4 years now, we've been planting vegetables in this garden here. And you can see it here on this side. We try to amend the soil, not go to Home Depot getting bags of soil. We hold on to our leaves, we save our food scraps, we make compost. We get wood chips from flagged down, people that are cutting trees down, and have them dump them in our yard, keep the wood chips, and you can see all the wood chips on the ground. So the ground now, after 4 years, went from this hard asphalt ground to, if you just dig up anywhere in this whole tennis court now, there's just so much life going on, earthworms and just all the birds, and so much life in this tennis court. We call it a food court now. And you can see some of the things we got here, tomatoes, like all the vegetables here. These are potatoes. My friend helped me harvest all the potatoes with her grandson. These are called chocolate peppers from Mexico, and I grow them every year and make crushed red peppers like that you get at a pizza restaurant. I haven't bought McCormick crushed red peppers in years because we grow them all, and they taste so good. Here's calendula. So calendula is beautiful. The pollinators love it, but then I dry it out and I make my own calendula oil and calendula lotion, which is really good for your skin. And then we are farm assessed because we have bees. We are not beekeepers. We have someone who keeps the bees, but we make honey. So this is the honey from our bees. And then the vegetable garden also provides a lot of pollinators like sunflowers and echinacea and a lot of other flowers to bring back to the hive to make the honey. So we have a lot of pollinators also. And you can see around here, we plant 40 pounds of clover each year.
Clover seed. Yeah.
Clover seed. And clover is the new rage for grass. Clover actually is a nitrogen fixer. So instead of using Chemlon to throw fertilizer down, which is usually a water and goes down into the sewer, half of it, and just gets, goes into our water system and we lose it. It goes into the river and causes algae. The clover just naturally fixes nitrogen. So it's a symbiotic relationship with grass. So this is a new thing for me, and I'm really excited about it because, like I said, we have a blank slate. We acquired a lot of oak trees, elm trees, birch, and but mostly a lot of oak trees. And Doug Talame is just an amazing scientist. He's a teacher at University of Delaware, I think. This is an awesome book. I can't say enough about buying this book, reading this book, or YouTube it. He has a lot of YouTubes on native plants. So prior to not very long ago, I would have been planting boxwoods and, just things for beauty. And that's like a one-dimensional reason to plant something, is just ornamental. When you find out about native plants, you realize that plants and animals were here way millions of years before we came here from Europe and colonized this place. And then we would bring in plants from Asia or from England, like a boxwood from England. And the nature, the animals, the insects, they didn't understand what to do with a boxwood or a regular, like say a Kuza dogwood. They had no use for it. It was pretty for us and they're beautiful trees, but there wasn't any use other than beauty. And so Doug Talame is trying to get everybody to realize that native plants are just as beautiful, but they have so many other dimensions to reasons to be having them in your yard. First of all, because they're native, you really hardly have to do anything to them. So you save a lot of water. You don't have to put chemicals on them. You don't have to fuss with them. But the biggest thing is they provide food and housing for so many insects. And for example, an oak tree can be a benefit over 500 kinds of caterpillars. And what Doug Talame talks about caterpillars, a lot he talks about caterpillars, is because birds like the one you see in the front of his book, one little chickadee needs 2,000 caterpillars to survive. And that's just to be a fledgling. So what's happening is when we have just a lot of boxwoods and ornamentals, there are no caterpillars, there are no butterflies, there are no moths. So a lot of songbirds and birds are kind of going extinct, or we're losing populations because we need to bring nature back to our yards and have more dimension to all of our plantings. And they're also good for not only like food and housing, but like native plants have flowers, so they have pollinating, all like native bees instead of just honeybees. Different bees need different kinds of honey, pollen from different kind of trees and perennials and things like that. So it just brings a whole new level of wildness and excitement to changing your yard to make it just full of life. And this is just a really cool picture of a blue jay with an acorn from an oak tree. And their beaks were formed to be able to break that acorn, and then they throw about 5 acorns different places, but they forget about half of them. So they're planting oak trees at the same time. So yeah, so there's our house going up. There's the inside, and you can see again the blank slate. So I'm really excited about what we can plant here to bring life back, more life to this property, and then just watch what happens. It's really exciting.
And while you're there, you see Diane's email on the bottom. If anyone is really serious about building a house like this, you should come and see. As we did, we went. It turns out we're the 3rd Unity house in New Jersey. We went and saw the prior 2. So it's really helpful to do that. So to that end, if anyone wants to come and really check it out, contact Diane and set it up. We're happy to show this to anybody.
Another thing, 2 resources for native plants. And what Doug Talamay would say is, don't rip up your whole garden, but if you're thinking of planting something new, think of doing it native instead of just regular old ornamental. You can go to newjerseyyards.org, and there is such a resource of plants. And then I am now a part of the Native Plant Society of New Jersey, which is a really great group. We get together occasionally, and there are a lot of classes on native plants. And Doug Talamay is also doing a new thing. It's called Homegrown National Park. And I just think it's such a great idea. He's saying that most land in the United States is privately owned. And so if we all put native plants in, if we could all do this, and there's a map, so you can put yourself on the map. And if you can do this, sign up. If we all planted native plants, the homegrown national park would be bigger than all the parks combined in all the national parks in the United States. So that's pretty exciting, how much wildlife we could bring back to this earth just from one backyard at a time. So that's pretty cool.
So yeah, that's it. I'm happy to open up for questions. Matter of fact, I see one already. Who was our general contractor who we were bragging about? His name is Tommy Gemilaro. His firm is called TKO. It's Tommy and Kids Operations. His son works for him. And I can't speak highly enough of them. We have a friend who used him prior who loved him and said she would never use anyone other than him. And so we tried him out. We had been talking to one guy who built the first Unity home, or no, the second Unity home in New Jersey. But he was pretty far away, and he wasn't too excited about commuting an hour and a half every day to do this one. And Tommy's local, and he worked out fantastic. Unity loves him because he's very engaged. So if you contracted with Unity to build a home like this, they would probably suggest you use Tommy. So if anyone wants his direct, Tommy Gemilaro, TKO Operations, contact Diane. We'll give you his phone number. Amy.
That's great. Thanks. The next question is not a question, it's a comment, but someone says that she's ready to come over and visit. So you're already getting people that want to do that.
Okay.
Nancy asks, does your air need to be humidified in the winter and dehumidified in the summer?
To be
determined. Explain that again.
Yeah, I mean, if we go back to the ERV thing, it handles. There's 2 kinds of things. There's ERVs and HRVs. So HRVs are heat recovery ventilation, and ERVs are energy recovery ventilation. And I was very confused at first, like, really, what's the difference? But put it this way, ERVs handle humidity and temperature. So that's why we picked that. I hate humidity. So, to answer that question, we'll see. But right now, you can see, like, even on this thing from the app, The supply air in our house is 30 degrees, and that's a nice, comfortable humidity. When outdoors it was 47. So the thing was already controlling our humidity in the winter. And I think it'll do a good job in the summer as well.
Okay. Well, another question about that has to do with humidity. It is just questioning it. Concrete on soil for your first floor.
I see that.
Does
It is, it's a complex thing. It goes down 5 feet, and then they have soil, and then they have gravel, and then they have insulation, and then they have concrete. So it's like a lasagna of stuff, 5 feet deep. So it's a little complex, even though it looks like a slab. It's a lot more. So yeah, and you know, one of the things we were thinking, hey, we should put radiant heat in here in the floors, and the Unity is like, absolutely not. It's way overkill. You don't need it at all. So
The floors are warm. You would think maybe a slab would be cold, but because the slab is not just a plain old slab, it's it's too bad we don't have like some kind of how it developed, but it's very complicated. The blueprint of the foundation was very complicated, and it was so that the slab itself was insulated.
I see the next question. How do you keep the deer from eating everything? Well, that was the genius of turning the tennis court into a garden, because it's got a 10-foot fence around it. So there's never been a deer in there since we put the garden there. We did have an issue with some woodchucks. They were kind of burrowing under the fence. So we actually dug around it down 3 feet and put more fence down below. Plus our dogs kind of convinced them to move elsewhere. So we don't even have, so really, you know, the only thing getting in the garden are birds. So they can fly in and, you know, do what they do. But no deer, no raccoons, nothing else is getting in there.
yeah. Right before that, there's also another question about the insulation, and I'm not sure I remember what you said about the insulation
It's
for the walls.
The walls are 18 inches thick. Let me get my hands here. They're 18 inches thick. And in that factory where they make them, they pack cellulose in tightly, much tighter than you could do if you did a stick built house and then poured it in. So they compress it in. So those panels, when they put them up, they're really solid and they're really well
And
insulated.
there's an envelope on the inside of there.
Yeah, then there's like a thermal envelope on the inside. So
And
it's like a balloon, sort of, really. So it's very efficient.
Another comment. You probably know, Anne. I would love to visit your garden sometime.
Sure.
I'm thinking to heck with the house. Let's visit the garden.
Sure.
I love garden tours anytime.
Kathy Jasenica, can ERVs be retrofitted? Sure you can. I mean, that unit we showed you, that's one of the more expensive ones. I think it's like $4,000, but you can put it in any house. And even if you have a leaky house, all right, but it's still going to be doing the majority of your ventilation and recapturing close to 90% of the heat, you know, transferred either way, recapture the heat or the cool as appropriate. So yeah, I think you could put it in any house, and it'll help. But you know, an airtight house is even better.
Okay.
Septic.
Septic system. Do you have septic or town sewer?
That's a good question. So when we bought this house, it was listed as sewer. And okay, it's fine. And then we started building the new house. And Tommy, our GC, is like, you know, where's the sewer connection? You know, we can't find the sewer connection to the old house, so we got to get a new one. And then, you know, we started looking at it closer and closer. And then we got the sewer plan of the town, and we realized, no, this house is not on sewer, it's a septic. So they started looking around, well, where's the septic? It was hard to find where the septic was. So we actually had existing septic, which means then we got to build a new one, because the old one had to be, you know, as old as the house was. It's over 25 years old. So we had to build a new septic system. So we have septic now because that's where we're located in Middletown. They did not give us permission to go across the street, and it would have been like 500 feet across this, further across the street to tap into the sewer system and uphill a little bit. So it wouldn't have been a great, sewer solution.
Okay, I think by the next question, Ennis is planning on building your house on his own. He wants to know what's the brand of the heat pump, the brand of the windows, the brand of the doors.
Okay, the heat pump's Mitsubishi, and I didn't even tell you about that thing. It's really cool. Like the heat pump has the internal things, and those are super smart. So the internal thing we have on the ground floor, one in the ceiling, and then one on the wall of our master bedroom. So two, and then on the upper floor, we've got a ducted system, so it comes through ducts. But the ones downstairs have these sensors on them that break the room into, I think, like 276 cubes, right? So whatever the space is, they break it into 9 times 9 times 9, I guess it is. In each cube, it's measuring the temperature of each cube with an infrared sensor. And so it knows, hey, if it's colder over there in the back, it's got to send heat like over to the back, and it'll adjust the ducts to send the heat to the back. So wherever it needs to. So that's really cool. And it knows where people are. So you can tell it, I want you to blow the cold air on me, or I want you to blow the cold air away from me. So it'll always be watching where the people are and doing what you want. So the thing's really thinking all the time. So that's the Mitsubishi system. The windows are called Logic, and they're from Europe. And so far we love them. They're really, really great. And what was the third thing? Doors. Diane and I picked out the doors. We could get back to you on the doors, but that was one of the things Unity, like, hey, go figure out what kind of doors you want. And we like nice solid doors. So they are, but I forget what the
Well,
brand
I
is.
think there's still
We picked them.
some
Or
kind
they
of
give us
passive
some-
house door.
Yeah, Unity they'll give you choices. You can choose a door. You get these, or these. And so we went and looked at all their choices and picked one.
If whoever is saying that wants specific models, you can email me, and then John can give you all the list, in an email. That might be better.
Yeah, there's no secrets. We're happy to share everything.
And the one thing I can say is, in a regular old house, normally you go in the basement and you see these big monstrous machines, like a big furnace and a big air conditioner outside. And you don't need a machine room here. The heat pumps the compressor is just one small thing outside, and there's a brain to it up above our closet. And then the ERV is up in another kind of storage attic kind of area, with like a hatch in case a maintenance person has to get there. So it looks like there's no machines here. You don't see any machines other than the water heater. You'll see nothing, and you'll hear nothing. You don't hear any machines going on and off. It's just magically working. It seems like.
Where is the water heater?
It's in a little closet off the kitchen.
Okay.
And I see a question, heat pump water heater brand. Yeah, it is a heat pump water heater as well. The brand, I kind of forget, but it was the same thing. One of the other houses that we visited, the guy was bragging about it. So we got the same thing.
It's really efficient.
And HVAC guy we used, Aggressive Contracting. He's really up to speed on these things as well. So he liked, or even recommended what we got as well.
Okay. Steve, you're making comments. I'm not sure why you're writing these comments in. Just oh, you're just copying John's.
Yeah, I'm answering the
answers.
questions. I'm trying to repeat the answers to the questions.
Oh, okay.
There's
So I
another
don't
question.
need to repeat those.
Yeah, there's a question, do your allergies and stuffiness disappear because of the air being filtered?
Yes,
I think so.
I think so.
I mean, I'm usually stuffy in the winter too, and we've only been in here 2 months, and maybe it's a mild winter, but it feels better to me. and Diane too.
Yeah.
Diane's always feeling like, the changing the filters in the old house every, couple months. And she feels it, when there's stuff on the filters. But here we went and looked and they're really clean even, so we haven't, we cleaned them, but they weren't very dirty.
Here's a question for Diane. What is the maintenance requirement of a clover lawn, and what's the ratio of grass seed to clover?
Well, if I had my druthers, I would have 100% clover. I don't see, because the clover again has more purpose. Grass is just overrated. It was like something we thought was prestige to have grass, but you can do any kind of percentage. You could probably Google what would be a really good percentage, but I say the more clover, the better. And then Dutch white clover is the clover you'd want, because the flowers are really come up really, and they're really short. So, you don't want to cut the lawn right away because you want the flowers to be there for all the bees. I mean, there's so many pollinators that thrive with Dutch white clover. So it's not just a nitrogen fixer for the grass, but it serves another purpose for pollinators. And I mean, I'd say the more the better. And the thing is, when you do cut the grass, it just looks like green, and then the clover comes back up in a couple of weeks or a week. So it's great to have a lot of clover.
Okay, Formina is asking how much glass window do you have, given that you needed 18 inches of insulation? I guess you did explain the windows, but it's not clear how they fit in the 18-inch walls.
Oh, you can show that. You can
let's
kind of see it in the.
Yeah,
picture.
we got a picture.
Yeah.
So right there, you can see that's just the inside.
So you see there's a shelf.
The outside is about the same as that, and the window's kind of in the middle. So the thing is, they didn't make the walls 18 inches thick because we have a lot of windows. They make those walls that way anyways. We did have a little bit of a back and forth with Unity about windows because they prefer really small windows. So they go, hey, here's one of our things. And the windows are these little tiny things. They look like portholes. And we like big windows, like, well, we want more windows, and they go, well, that's a trade-off. You're going to lose heat through those. Well, we're willing to put up with it. But so far, the results look really good. But so we got more windows than probably the normal, what they would like, to achieve the highest performance. But we like the aesthetics of having a lot of light and open windows. So we did.
You can see how much space is, the window is still a normal skinny window. So there's a big window sill, which is kind of great because you can place something on it decorative.
Yeah, you can see
and then on the outside, you can see it's not as much, but so it fits in kind of nicely. It's like a little smaller on the outside and a little bigger on the inside.
There's the outside portion you can see, and yeah, here's the inside portion. So
see on our house too, I'm sure.
Yeah, well, that is our house. That's nice. But yeah, so there, yeah, it's hard to.
Yeah,
we didn't really take a good picture of that.
You can kind of see how the window is in more than the average house. So, but I like having the big windowsill. It's nice.
Great. David wants to know how much the heat pump water heater costs. And if you don't remember that, Steve could probably tell him how much ours costs.
We can dig out the stuff. I did a good job of keeping all the bills. And actually the deal with our contractor, we worked out a deal where, rather than paying one fee, we see everything. And so we could put things out to bid to various people, see all the bids, and we'd see all the things, and we'd pay all the subcontractors ourselves. So we have all the bills. So we can send you, the actual Mitsubishi heat pump water heater.
Yeah.
I don't know if that
Well,
water
the
heater was Mitsubishi or not, I forget.
How much was yours, Pat and Steve?
It was slightly over $2,000.
just for the heat pump
Just
itself,
for the
but you
material.
also have to have installation, and Steve didn't. Steve's labor was free.
That's great.
So the labor costs can be as much or more, and you also might, if you're putting it in an existing home, you have to make sure that you have the electrical hookup for it.
Yes.
If you're changing from a gas water heater.
And you
So
have
Steve did that also.
You have to have enough amperage. Yeah. I see a question on the JCP&L rebates for some of these things. At first, we were really, excited about getting all the rebates we could. And we kind of found out there was about $7,000-ish and maybe more, depending on how the house performed, that we could get. So we were eager to do that. And then it turns out to do that from JCP&L and the state, to get the state programs and Energy Star and all that stuff, you have to have a consultant. So we used one called Revero, and they were such a pain in the butt that we ended up firing them. And their fee was going to be about $3,500, which worked out to about half of what the rebates were going to be anyways, whether we got the rebates or not. So at the end of the day, we were on one conversation with them where they were just annoying the heck out of us. And we just said, you know what, forget it, we're done, we don't care. So we didn't go for any of those rebates that you require the consultant to get. The whole thing seemed a little bit of a scam or double dealing. And we didn't do that.
Okay. The next question was just about the solar, because she missed it because she had to take a call, so she didn't hear you talk about your plan for getting solar.
I didn't, because, and I meant to. Let me go back to that slide.
Well, I think you did say.
Well, right now we don't have solar yet. We would need to get some actual utility bills and with actual readings before they'll give it to us. But here, this is the thing where I was doing my own meter readings and looking at our usage. And here I estimated how much solar we'd need to cover 100% of our usage. So it would be, I think, about 20 kilowatts, which is a pretty big thing. 15 kilowatts seems big for a house, and we're more. But again, our vehicles are almost half of our total use, or equal. Our vehicles use almost equal to what the house uses, the electric vehicles. So it's really, right here, I actually broke it down. Based on the best I can tell right now, we'd need 11 kilowatts for the house and 9 kilowatts to power our vehicles, all the time. And then, of course, we need batteries and all that stuff too. So, because we're probably driving our vehicles during the day when the sun's out, not charging them.
And Maribel also asked, do you do any water reclamation for your garden?
No, we wanted to. We were going to harvest the water off the roof and put it in a cistern. Again, with how much everything costs, it would be another cost, and so we kind of put that on the back burner. In our old house, we had a lot of big black water barrels holding the water.
Which 600 gallons, which wasn't really that much.
Yeah, it didn't do much.
Sounds like a lot at first, but then when you see how fast it goes, it's not.
But I would love to harvest the water off the roof. I would love to have rainwater and water the garden with that rather than chlorinated fluoride water from my hose. But at this point, no, we don't have that.
That being said, all the gutters go underground and then go towards the garden and pop back up. So it puts a lot of the water We're very close to the garden, but no, it's not for irrigation directly.
What I'd like to do, another project, is some rain gardens, because we have some wet, because of the because of that, there were three gutters are all focused to one area of the house and then 3 to the other. So there's a lot of water there. So it's a perfect place to make like 2 or 3 rain gardens. So that's one way at least of capturing the water and using it for plants and bringing it back down into the earth that way.
Okay. Here's a question about the insulation on your roof. Is your roof also 18 inches thick?
Yeah, it is a good question, but it is. And the garage too, we insulated the garage as well. We store some stuff up there too. So even though the garage isn't part of the living space, the garage itself doesn't have the 18-inch thick insulated stuff. It's more regular construction, but we put insulation in there as well, traditional.
Okay. I don't know if you're going to know this, but would the hot water cost equate to about half your annual electrical consumption?
I
Or
don't.
the house. I'm sure he needs the house, not the EVs.
I don't know the answer to that. I would think probably not. I would think it's probably more heat pump, but maybe. Yeah, and we have all LED lights everywhere too. But
Well,
yeah, that's a good question.
2 people don't use, I mean, our experience is that our hot water is a whole lot less than heating. Of course, we don't have a passive house either, but the amount of water that 2 people use is not a whole lot.
Right.
You guys use natural gas to heat your hot water, right?
No.
No, we have a heat pump.
Oh,
Do you have a heat pump for the hot water?
Yeah.
Okay, I remember at some point in the past, I thought you said you were using natural gas.
Oh yeah, we only got it last fall, so we've only had it for a few months.
Yeah, in most homes, in America, the hot water, because water is so much denser than air, takes substantially more energy to change the temperature. So it typically involves anywhere from 25 to 35% of the household electrical consumption. Given all the efficiency activities that they have integrated and done an impressive job doing so, and given a very, very knowledgeable and helpful presentation, they may want to have a closer look at that because there could possibly be ways that they may make recommendations for it is within the realm of possibility that they have the opportunity for a further 25% reduction in their electrical consumption.
Okay. Ennis is asking what brand of heat pump does Steve and Pat have? Do you want to answer that, Steve?
Yes, for anybody interested, I have information from a recent heat pump vendors conference where all the leading best brands were discussed, and I can send that information. Whoever wants, just email me, stevemiller@comcast.net.
Okay. Let's.
the guy that was just asking about the water heater, heat pump consumption, we can probably figure that out because we have this new fuse panel, like a smart one that I think every breaker tracks its own thing, and you can hook it up to your phone. And so we can probably figure out what breaker that thing's on and see how much power the thing's using through there.
Yeah.
Possibly the thing even might have its own app. So everything nowadays has its own app and tells you how much what it's doing. So maybe we can get some concrete answers on that.
Usually on the either is the heat pump integrated into the you have a hot water tank, right?
Yes.
And your heat, is it integrated? Is it part of the hot water tank, or is that a separate unit?
It's on top of it. So it's kind of like one big hot water tank with a thing on top.
And all you got to do is you might be able to just walk over to your kitchen, open the door. There might be a placard on a tank.
I was thinking
exactly what it costs.
I was thinking I could go down here and tell you the answer in a minute. If you got to know, I could do it. I'll be back in a minute.
If it's all integrated, if it's integrated into the hot water tank, there's going to be a placard on the water tank that tells you how much that costs. But when you're looking at that placard, you also want to take careful note of the listed cost per kilowatt hour, because there's a slight little advertising thing there. Sometimes they'll have the placard on there and it says this water tank costs $182 per year. And then if you look closely, it says based on 4.9 cents per kilowatt hour. Well, I'm paying 13 cents per kilowatt hour. So it's going to cost 3 times that much. But at a glance, it looks like it's less expensive. So you want to look at the cost listed on the placard and the estimate for the cost per kilowatt hour. And then all you got to do is take out your electric bill, take a minute and look at it, and you'll be able to tell the difference pretty quickly.
Okay. I don't think we have any more questions in the chat. If, well, John's not here. Diane is here. If you have any questions about Diane's part.
Yeah. Well, that was a lot of questions. So it seems like we covered a lot of topics, and hopefully we answered all the questions. And really, anyone who wants to come see the house or the garden, we're excited to be here and would really like to turn people on to doing it. Unity, you could even take our blueprints and make the same house and not have to go through what we did. Do you know what it is?
Yeah, so I think the heat pump water heater is A.O. Smith. There's a big thing on it that says A.O. Smith. I don't know if that's the manufacturer or I think it's the manufacturer, because our contractor was aggressive. It also had a plaque that said anticipated annual energy usage is $173. So how it calculated that, I don't know, but that's what it says.
Okay, well, Steve, do you have any final words? Or did John and Diane have any final words?
Could Diane put her email back up?
Yeah, here we go.
Have a look at your electric bill, see what you're paying per kilowatt hour. It's probably around 13 cents, something like that. And then do the math. 1,000 watts for 1 hour of use costs you 13 cents. And if it's $182, it'll tell you exactly, depending on your amount per kilowatt hour, how many kilowatts that's anticipated to use for the year. And normally, another way that those placards are less than accurate, they normally tell you what it is for 2 people in a home. So if you have 2 people in your house, it should be fairly close. But if you got 4 or 10 people in your house, it could be vastly different.
Well, I really appreciate John and Diane for answering all the questions and giving us this great talk. I'd like to put in a little plug for the next 2 webinars. One is April 20th. We have 2 informative speakers. Bill Ammon, who's a longtime climate evangelist and president of M&E Energy Engineers, will give you rock solid advice on the best practices using heat pumps in energy efficient buildings. And Alan P. will enthrall you with his story of designing and planning to build the ultimate net zero beach house. And then I finally, a plug-in for Pat and myself in a week and a half, March 27th, we're featured during a Sierra Club Science Monday at Brookdale Community College, but it's hybrid in person. You'll probably be receiving the webinar link as well. If you pay attention to announcements, please do. It's the title.
And register.
And register. And the talk is called Save the World from Climate Destruction. by moving yourself toward net zero energy and net zero greenhouse gas emissions. And that's it for this evening. I thank you all for attending. We'll see you at the next webinars.
Thank you.
Thanks,
Thank you.
guys.
Take care.
Thank you. That was
Have a
great, John and
very
Diane.
presentation.